Hello there. So this time I get a question about object-oriented programming and actually what happens when you create a class and then you create an object of that class and another object of that class. Do the methods which you have in that object, are they actually duplicated in the memory, or is there only one instance of a method? But in that case, how does the method know on which object to operate? So I'm going to answer this question in terms of C++ and Python. It might be different in other languages, but generally the rule of thumb is that no, there's only one instance of each method, and there's some way to bind the method to a given object which is supposed to work on. So I'm going to start with C++, and my code in C++ is somewhat simple. On the other hand, I did complicate it a little. First of all, please ignore this separator thing. It's just to be able for us to find the given place in code in IDA faster than, well, just trying to figure out what is what. So I'm going to use these separators all around, and they're just to make the assembly code cleaner, because we are going to look at assembly code. Now, the first class I created is actually, it's actually called my class, and you're going to focus only on this part which I highlighted. And it has one method which is called method, and well, it doesn't do anything interesting. Anyway, so what would happen if I would create two objects of that class, and I did create two global objects, though it doesn't really matter, and call the method method. So here's the piece of code responsible for it, and yeah, there's no magic here, just creating two global objects and calling the method. And let's see how it looks like in assembly. So I did compile this, as you can see, already. And I did compile it also with -c option to have an object file, because having an object file makes it a little easier to browse in IDA. This is the code which is responsible for the two calls which are there. And as you can see, in both places, we actually put a pointer to the object in the RCX register. And the same happens in the second case. This is the second object, obviously. But we call the same method. So basically, this means that we have only one instance of the method in library, one instance of the code for the function. And we put in some special register RCX. In this case, it might depend on the compiler and actually the calling convention. The calling convention used here usually is referred to as this call. Now, the RCX register gets basically the this pointer, which we know and love from C++, which refers to the current object which is being worked on. So, yeah, as you can see, this is the answer to our question already. We have only one instance of the same method, and it operates on the RCX register to have a this pointer. Now, things get a little more complicated if we actually go and create a derivative class which has which inherits over my class. And actually, we do have some virtual methods as well. So in this case, I created a virtual method. And if we scroll down my code, I actually create a pointer to my class. And this is, I guess, the behavior which I'm going to describe is strictly related to pointers and pointer-like objects. So for example, unique pointer, which would be better to use here. Don't use new unless you have to, seriously. Anyway, so I create an object, my derivative, and both my derivative and my class would be, both objects of these types would be actually proper objects to be put under this pointer. But, well, how does the compiler know which virtual method to call in this case, right? Because the compiler actually only sees a pointer. For all we know, this could come from like some external DLL library which is already compiled, and the compiler has just no idea what type is there, what type is underlying there. Now, well, unless the compiler would boil down to reflections, but let's not go there. It's too complicated actually to be used here. It would be too slow. Now, what happens here is that something called the virtual table is created, which is a table of virtual functions, and each object actually at the beginning has a pointer to the virtual table. And the virtual table related to a given pointer is basically related to the base class from which the pointer was basically created, right? Or the pointer to the object from which the object was created. So that means that when I do this call, and then later when I do the second call, actually the pointer would point to a virtual table, and the virtual table in both cases would point to different virtual tables, which we can see in IDA. So this is where the new operator is being created, well called to allocate memory, and this is where the constructor is being called, because the constructors are always invoked, even if we don't see it, right? And if we don't define one. Now, here we can see the actual calls, and as you can see, there is some magic happening here. Now, this magic is actually getting a pointer to the object and then getting the virtual table address from there and reading from the virtual table the address of the method to call itself. And as you can see here, the method is being called. Now, in KrzaQ, we are basically getting the pointer to the object, right? So this is again just a this call, just the this pointer. And in KrzaQ, we already got the method resolved, and this is exactly what's happening later on as well here. So I guess what is left to do is basically to inspect the object to see what's going on inside it, where is the virtual table located. And it's usually, but it depends on the compiler, it's usually the first entry. So this offset at the beginning of the object would be the address of the virtual table. So if we jump there, we can see that there's only one pointer to the virtual method. I guess it's not fully readable, but in the comment it's a little more. We just have a pointer to a function there. So this is how it works internally. Now, we can also look at Python, do a really quick check how it's working, and Python is a little different there. So let me close this and let's get to Python code. In Python, there's actually something called a bound method. So basically when we create a class, we do define a method there. Now, this method is basically a standalone function already. So if we would pass it explicitly, tell it, please operate on this object, and this is exactly what's going on here on this line. We call myClass.method and we explicitly pass it the object. It would just happily work. Now, when we create a new object, and this is what's happening here, we basically get a bound method. So this isn't pointing exactly to this. It's not pointing here. It's actually pointing to a new bound method object, and the bound method object has three interesting fields. Let me maybe move the window a little so it's better visible. Now, the three fields are I am self, which is basically the same as the this pointer in C++, but we call it self in Python. Then a pointer, well, not really a pointer, these are references, of course. A reference to the function object, which in our case is myClass method, and then we also have a reference to the class object of the class which we created the object from, which is myClass in this case. So yeah, let's run it and let's see what's the output. So python test.py, and we can see a couple of things here. So first of all, when we see what the method is bound to, as in self, well, it's actually bound to the object, and the object is created here. We can actually see that in memory, these are in-memory addresses. In memory, this is exactly the same object, so we are sure that I am self points to this object which we created earlier. Now, if we look at the function, it's actually the method which is, it's just the method which is here. So this is basically the same function which is we have here. It's basically, I think there's like one more object there in play, but it's not important for the considerations we're doing right now. And IAM class just points to the class which we created, and having this bound method actually allows you to just give this bound method object to as a callback wherever, and then when you run this callback, the bound method knows to which object it's actually bound, well, because it has a field IAMSelf which tells the story, right? Please note that this is not the case in C++, for example, because in C++, if you want to call a pointer to a method, you actually have to supply explicitly the object which it's supposed to operate on. So I think this kind of clears up this question. Again, there's only one instance of bytecode or machine code for a given method, in case of object-oriented programming, so you don't have to worry about if you create 10 objects, you will have like the same really long method, for example, 10 times in memory. That's not going to happen. There is a rather clever mechanism in play here, be it done by bound methods or the compiler knowing what to do or vtables. So that's it. Thank you and see you next time.